Yes, good day. Greetings to all. The topic for the today's discussion is subtractor. In the earlier topic, we have discussed about what is meant by adder and what are the different types of adder. Now, in this session, we are going to discuss about what is called as a subtractor and what are the different types of subtractors in use. As the name itself instincts, the subtractor is the one which subtract two bits, two binary bits. So the first type of subtractor that we have took under the study is half subtractor. This half subtractor is used to perform two binary digit subtraction. Let the binary digits be your A and B, and the output is two outputs. One is difference and next one is borrow. So difference means is the difference between the two inputs. There are the two inputs can be termed as one is called as your min1 and next one is called as your subtrahend. Whenever your min1 is less than your subtrahend, then there will be a condition to borrow a bit from this borrow. If the min1 is less than the subtrahend, then we will be using this borrow bit. But whereas if the min1 is greater than the subtrahend, then there is no need of any borrow. Then you will get the difference bit asserted to be logic high. So the truth table for this 2-bit half subtract is let A and B are your 2 bits, input bits. They are 0, 0, 0, 1, 1, 0 and 1, 1. Here A is called as your min1 and B is called as your subtrahend. Now see, 0 minus 0 is your 0. So your borrow is 0 because both min1 and subtrahend are same, one and the same. So we are not getting any borrow from this borrow bit. So it's 00 for the input 0 and 0. The difference is 0 and as well as borrow is 0. Whereas if for the next input of 0 and 1, here min1 is 0 but whereas subtrahend is 1. If your min1 is less than your subtrahend, then we will be using your borrow bit. When then you make the borrow bit to be your logic high, you borrow 1. So when that 1 is getting added with this 0 means that will become 1 0. 1 0 minus 1 is your 1. Okay, then the difference is 1 here. Now 1 minus 0, A is 1 and B is your 1. Your min1 is greater than your subtrahend, then there is no need to take any borrow. So 1 minus 0 is your 1 and the fourth input is your 1 and 1. When both the inputs are same, this 1 minus 1 is your 0. Here also there is no need to take any borrow. When we plot a k-map for the expression for the difference and as well as the borrow, here the two variable k-map is used because we are having two inputs as A and B. Here A and B, A is on this side and B is on this side. A means A dash, A bar and as well as your A and B bar and B. It can also be expressed as 0 1 and 0 1. The difference is 1 for your input 0 1. So for your 0 1 the difference is 1 and next one your difference is 1 for your 1 0. The difference is 1 for your 1 0. Here also 1. This cannot be grouped because both are in your diagonal side. Then we can single grouping is possible. So this can be written as your D is equal to A B bar plus your A bar B, which is an XOR operation and that could be expressed as D that is equal to A XOR with your B. When we want to do for your when we want to draw and k-map for the borrow, two variable k-map is used. So your A and B 0 1 and as well as your 0 1. The borrow is high for your input 0 and 1. So for your 0 1 it's your 1. So your B that is equal to your A bar into B. The logic diagram for the half subtractor is your input is A and B. When they both are XORed, we will be getting the difference to be this, okay, which is A XOR with your B. When we want to find the carry for this, we have to invert this A using an inverter that is called as your IC7404 and B is given directly to an AND gate which is IC7408. Here the XOR IC number is your IC7486. So the difference in borrow is achieved. And now we are into the topic called as your full subtractor. This full subtract also comes under the chapter of your combinational circuits, that too after the half adder. So this performs subtraction of two bits. Okay, one is your min1 and next one is called as your subtrahend. Okay, taking into account of the previous adjacent, okay, previous borrow, taking into account of the previous adjacent borrow. So this could be given as A, B, C are the three inputs. One is min1's upper hand and next one is called as your min1's next previous bits borrow, okay, and this is your difference and as well as your B out. So the truth table can be, instead of writing a C, okay, that could be taken as your B in borrow in. So total number of inputs is 3 inputs. So your input combinations can vary from your 000 to 111. Here D is your difference and this your B output. The difference can be, so when this your min1 and this your subtrahend, okay, min1 and subtrahend, and this is called as your borrow of the previous okay. So when you take this 0 0 and 0, here the difference is 0 and borrow is also 0. Here now we can see here min1 and these both are, this is your subtrahend, okay, 0 minus 0 is 0 and 0 minus 1 means your min1. Now here the min1 is your 0 and your subtrahend is your 1, okay. When your min1 is less than your subtrahend, then you want to give a borrow, then you want to get a borrow. When you take a borrow of 1, that becomes 10. 10 minus 1 is called as your 1. And next one, so your 0 minus 1 is your 1 and your 1 minus 0 is your 1. So here you see this is your min1 and this is called as your subtrahend. Here min1 is less than your subtrahend, so you take a borrow, that becomes 10 minus 1 is called as your 1 and your 1 minus 0, okay, so this is called as your 1 minus 0 means 1. Now here also min1 is less than your subtrahend, so this you take a borrow, this becomes 10 minus 1. 10 minus 1 means 1, then 1 minus 1 is 0, and then now 100 means 1 minus 0 is your 1 and your 1 minus 0 is your 1 and here borrow is 0 and here the min1 is 1, so you don't want to take an borrow here. So 1 minus 0 is your 1 and 1 minus 1 is your 0, and when you take this 1 1 and 0 means your 1 minus 1 is 0 and 0 minus 0 is 0, so 00, and this 111 means 1 minus 1 is 0. Now here it is 0. When you compare these two bits, this is your min1, this is your subtrahend. Now you take a borrow here, so this become as 10 minus 1 which is equal to your 1. This is the complete explanation of the truth table of your full subtractor. When we draw the K-map to get the expression for your D and as well as your B out, you will be getting an K-map as equivalent as the sum bit of your full adder. So this will give you the input as your A XOR B XOR with your C, because we will be getting only at the diagonals, only at the diagonals, but whereas your B out is equal to A bar B in plus your A bar B plus your B into B in, which is achieved, okay, which is achieved by giving 1 for, okay, so your B out is 1 for your 001 and your 010 and your 011 and your 111. When you plot that and you group, there are 3 grouping is possible. After this 3 grouping, your B out will be your A bar B in plus your A bar B plus your B into your B in. The logic diagram for this is the difference bit, you can get it as this your min1 A and this your subtrahend B and your borrow in. Okay, when both have been took for your XOR operation, that output is taken to another XOR gate. Here one another input is your borrow in. Now this is called as your difference, which is A XOR B XOR with your B in. But whereas for the carry, it's called as your A bar B in plus your A bar B plus B into B in. We have to use 3 AND gates, okay, 3 AND gates, and the 3 AND gate input can be given to an OR gate. That is also one possibility, and there is one another possibility as when you take this A XOR B and that is directly given to an inverter, and the another input your borrow in B in is given to an AND gate, and finally your A and B are given to another one AND gate where this A is inverted using an OR NOT gate, okay, and this is called as your another input. So totally when you take both of these to an OR gate of IC 7432, you will be getting the output B out. such that here you can see this belongs to one half adder, half subtractor, and this belongs to another half subtractor. Both are combined using an OR gate. So a full subtractor can be implemented by using two half subtractors. To create a half subtractor, you need an XOR gate and an AND gate and a NOT gate. So here you are using two XOR gates, okay, and as well as your two AND gates and your two NOT gates to obtain the operation of a full subtractor using two half subtractor modules. And finally, excess of that you are using IC 7432 OR gate. Thanks for listening. Thanks.